Last week we introduced limit, so I'm going to go through the examples of limits that are in your workbook. I did put the page on the Google Classroom, so I'm just going to go through limits. I said that in practice basically limits means that if you can at any stage substitute a value into an expression and you get something that is credible, something like a number or a zero or something like that, then there's no issues with the limit. So in a case like this, the limit when x tends to 3 of x squared minus 3 over 3, if I was to substitute here, that would give me 3 to the power of 2 minus 3 over 3, which is 0 over 3, sorry, is 6 over 3, and that is equals to 2. So the limit as this function approaches 3 is equals to 9. So that is basic. What it means is that it is likely that as we get closer and closer to 3, the function gets closer and closer to the value of 9. In the next question, however, if I was to do the same as I did at the top, if you substitute 2 in this, you're going to end up with something like this. You're going to end up with a 0 over 0, which is something that has no meaning. So this is one of those cases where I cannot proceed to calculate the limit before I can do something. What can I do in this case? To be able to calculate the limit, I need to then factorize. So remember, I haven't calculated a limit yet, so I need to keep writing limit. It's essential that you write limit again. Limit when x tends to 2, and then what I'm going to do is I'm going to subfactorize at the top. So this is x minus 2 times x minus 2 over, and the denominator is x minus 2. I can now simplify this x minus 2 with one of these two, and that will give me the limit when x tends to 2 of x minus 2, which can now be easily calculated by substitution, and that limit is 0, which means that as x approaches 2 in this function, the value of the function is 0. And that's how you calculate your limits. Okay, let's do now the limits of a split function. In this case, if I'm going to calculate the limit, remember that I need to look at where I'm calculating. So I'm looking at to calculate the limit of that function when x tends to -1 or tends to 1 from the left. That little minus there means you're approaching the function from the left rather than from the right, and that means that I'm going to be substituting in this value over here because these are the values that are to the left of 1. Okay, so the limit when x tends to 1 of this function is going to be the same as calculating minus 2 times 1, and because that does have a meaning, that limit is -2. Okay, then we have to the next one where we say now the limit as x approaches 1 from the right. Now we're coming from the right. In this case, these are the values that are to the right of 1. So as I'm approaching the values of 1 from the right, the function has this value. So in this case, that would be equivalent for me saying 2 times 1, and that is equals to 2 is a numerical value. Now, what is the meaning of this? The meaning of this basically is that I don't have the limit from the left and the limit from the right are not the same. From last week's lesson, what can we conclude by that? That the function is not continuous at x equals to 1. And I could even go further, and because the limit from the left and the limit from the right are different, I could actually go further and say it has a jump discontinuity. Okay, right, so moving on to the next one. In the case of D, I've got this expression now at a glance. If you were to substitute the x by 0, you will end up with a 1 over 0 here, which is meaningless, and therefore I won't be able to find the value of the expression. So what I will need to do here first of all is I will need to work out these fractions. Now in grade 10 you may have learned how to work out these complex fractions. So when you have fractions like that, the best way to go about it is actually multiply by the lowest common denominator, and you multiply each and every term on each one of the two sides of my fraction by that lowest common denominator, which in this case is x to the power of 2. So I will say, remember, I haven't calculated the limit, so I need to keep the word limit when x tends to 0. And if I was going to multiply each term by x squared, that's going to give me x squared plus x over x squared plus 1. Okay? So at the top, what I could do here is I could multiply, or I could say, if I still substitute by 0 now, so if I just take it now and I substitute by 0, what am I going to end up with? I'm going to end up, my numerator is going to be 0, my denominator is going to be 1, and that has a meaning, it has a value of 0, so the limit is equal to 0. Alright? Okay, so